For Model 4, conservation laws, we need new conservation laws for rotational motion. For impulse momentum, we can simply take the old equation, and everywhere we see a delta r, replace it with delta theta. Where we had a v, we will replace it with omega. Where we have acceleration, we'll replace it with angular acceleration. And moment of inertia will replace mass, and torque will replace force. So our old equation for impulse momentum said the momentum, which is mass times the initial velocity, plus the impulse, which is the integral of the force with respect to time, going from t1 to t2, is equal to the final momentum, mv2. So we replace the mass with the moment of inertia, we replace the velocity with the angular velocity, the time stays the same, we replace force with torque, and then we have angular momentum times omega 2. That gives us our new equation for impulse momentum. And just like the original equation for impulse momentum can be derived from Newton's second law, this equation can be derived from Newton's second law in rotational form. For work energy, we're going to do something like this, but work energy was a scalar equation and not a vector equation. And so rather than having a completely new equation, so here, just like for Newton's second law, we can use the impulse momentum equation in the x direction, the y direction, and the z direction. And then in addition to that, we can use the rotational form. For work energy, we're just going to have one equation, and we're going to keep adding terms to it. So we had kinetic energy is equal to 1/2 mv squared. If the object isn't going anywhere, so if it's the velocity for the center of mass is 0, it can still have kinetic energy if it's rotating. So this is rotational kinetic energy. And we replace the mass with the moment of inertia, and we replace the velocity with the angular velocity. This gives us rotational kinetic energy, which comes from the object rotating, even if its center of mass is not moving. Okay, so then we go back to our initial equation for kinetic energy. Since we didn't do all of Model 3 yet, we can ignore those terms. So we have kinetic energy plus gravitational potential energy plus work done by forces other than gravity is equal to final kinetic energy plus final gravitational potential energy. And all we have to do here on the left-hand side of the equation, we're going to add in the initial rotational kinetic energy, so that's 1/2 the moment of inertia times the initial angular velocity squared, and afterwards we add in 1/2 the moment of inertia times the final angular velocity squared, and that gives us our new equation for work energy. On the next page, they give you total kinetic energy is translational kinetic energy plus rotational kinetic energy. The terms that I crossed out here only appear if you have springs in the problem, so if there are no springs or other elastic material, we have our equation here for Model 4, work energy.